One, two, three. Greetings, everyone. Welcome to the 18th International Conference on Artificial Intelligence and Law. My name is Jackson Souza, and this is the fifth panel of the second day of the event. Before we can start, I will present you our sponsors, our platinum sponsors. Jus Brazil is currently the #1 law and government website worldwide with 28 million unique users each month that makes high-value legal information super easy and quick to access, thus saving its users time and providing sustenance for their case strategies and insights. Their purpose is to improve justice, social trust, and transparency by democratizing access to high-quality and relevant information. They inspire to be the single source of truth for legal information. And Albert Einstein Israeli Hospital. Albert Einstein Israeli Hospital, one of the best known health units in Brazil and Latin America for the quality of care and for the equipment and medical specialties available to treat many types of pathologies. The hospital is referenced in treatments with state-of-the-art technology and humanized care, expanding its borders with social responsibility actions, teaching and research activities. With over 50 years of existence, the Albert Einstein Israeli Hospital still maintains a premise to innovate and grow, always with excellence. So, to start, we have a full paper streaming with the title Precedential Constraint, the Role of Issues, that will be transmitted and was given by Trevor Bench Capone. And the presentation has 20 minutes. You can start, please.
This is your birthday, Tf Idf. You see there, he's happy as rose when we could actually meet at ICAIL. That's in San Diego. My paper has three topics: the relation between factors, dimensions, and facts. And I will argue that precedential constraint is best expressed in terms of factors. And factors are assigned to applicable dimensions on the basis of facts. Precedence constraint issues is the second point. And it's issues that constrain cases. So when thinking about precedence, you also think about issues, not cases as a whole. Factors in cases should be structured into issues to avoid irrelevant issues. And the third topic is precedential constraint only needs factors. We don't need to express precedential constraint in terms of dimensions. Where magnitudes are important, and they are important, we first describe factors on the basis of dimensional facts, and then we apply constraints. So, the history of understanding precedential constraint is a lengthy one. At the very first edition, Embeddings and Heliassi presented a paper which understood them in terms of dimensions. In 1985 onwards, Cato, with Vincent Leaven and Heliassi, introduced the notion of factors. Then Henry Pachen and Giovanni Starfield showed us how we could write precedents as rules. My contribution in 1999 was to consider these antecedents organized in partial orders. And then still ongoing is work in formal characterization of precedential constraints. begun by John Hawley, continued by Adam Biennially, and summarized by Henry Clapham in a paper this year. So, how do we move from dimensions to factors? The dimensions tell us what needs to be considered in a case. If the dimensions are applicable, it may, not must, it may provide a reason to decide for one of the parties. These reasons are referred as factors. Factors refer the significance of the dimension in the particular case. Sometimes the dimension is either inapplicable or favours one side, in which case it will correspond to one factor. Sometimes it's inapplicable or neutral or favours a side, and the dimension may have more than one factor favouring the side to differentiate different degrees of favour. And sometimes the dimension may be neutral, or it may favour either side. And this dimension has distinct factors to the different sides. Factors should never be related. An action factor may be inapplicable, it may be neutral, it may be a factor for the other side, or a different, stronger or weaker factor to the same side. It's confusing to bundle these very different things under the yoke. So, moving from the dimension to a factor, let's consider the disclosure dimension. If we have no disclosures at all, the dimension is inapplicable. An insignificant number will lead to no factor. A significant number will lead to a factor, S10 in paper. And in the public domain, we have the very strong co-dependent factor, S27 in paper. So as we move along the dimension, it's first inapplicable, then neutral, then dependent, then strongly dependent. It never favours the plaintiff. Another dimension, security measures, can favour both the plaintiff and the defendant. So we have two distinct factors, S19 and S6. S19 applies if the measures are inadequate. S6 applies if they're adequate. So the dimension is always applicable, but there's a neutral area in which no factor applies. Precedents determine where these splitting points occur. S19 is not related to the aspect. It provides a reason for the defendant, but the neutral range does not. So now we consider how can we write precedents as a set of rules. A case can be seen as P union V implies O, where P is the plaintiff factors, V the defendant factors, and O the outcome. So P is the strongest reason assigned to the plaintiff. V is the strongest reason assigned to the defendant. And O will be either plaintiff or defendant, and will show which of these reasons is preferred. So we get three rules: a plaintiff rule, a defendant rule, and a rule expressing a preference between these, depending on the outcome. We can represent this graphically by representing the possible antecedents as two parts rulers. The one on the left for the plaintiff, the one on the right for the defendant. Now a precedent will place an arc between these rulers. So if we have A, B, C, D, E decided to apprentice, that shows that A, B, C is preferred to D, E. If B, C, D, E is decided to dependent, that shows that D is preferred to B, C. Now if we have a U case, it's constrained if it's a reproducible cycle. If we have a case A, B, C, E, then we can put the arrow at either end and there's no cycle. So we can do what we like with second case. However, if we have C, D, E, that's constrained to the descendant. If we were to decide to approach it and prefer C to D, E, we need to use the cycle. We can't have a cycle, and so we have to decide to the descendant. This basic idea has been formalized starting with John 40, going on to Adam Biennially, and finishing this year with Henry Buck. And there's a list of the papers. The formalization is rigorous, and it shows that all the desirable properties we would want to hold do in fact hold. And it comes in two forms, the results model and the reason model. The results model uses all available factors. No insert place is needed, both sides offer their strongest reason. But, unfortunately, it does not in fact constrain many cases. It only supports a tutorial reason. The use case, if it is to be constrained, must be subsumed under the pressure. But we want more than this. We want to be able to argue for cases which, while not subsumed, are constrained by the pressure. Suppose we have a case with security measures, invasive techniques, and disclosures are outside, and a precedent which has similar factors, but also the unique product. We want to say that the use of invasive techniques, such as wiretapping, is sufficient. The actual uniqueness of the product as little. But on the results model, the precedent does not bind because FAC is not there. And this is even though we have a much stronger factor, F6, in the use case. To rectify this, forcing to use the reason model. Now the reason model contains only a subset of the available factors. It represents a sufficient reason which, although it's not the strongest reason, is still enough to defeat the opposing reason. The losing rule still has all available factors, and the reason model has the same formal properties as the result model. But there are three problems. How to determine which factors constitute the reason? It's possible that cases are reinterpreted in the light of new decisions, which would disrespect the reason model rather than obeying the results model. And even the results reason model does not constrain enough cases. Irrelevant distinctions are still possible. To find the answers to this problem, we look back to issue-based prediction, which was introduced by Steffi Bruninghouse and Kevin Apple. Whereas Plato was designed to generate arguments, not to predict outcomes. So it didn't matter whether there was constraint or not. the user evaluated the argument. But when case service is active contradiction by setting evidence, they found that HATO abstained on far too many cases. Case service is considering irrelevant distinction, like the unique product in the example earlier. So HATO instead considers cases issue by issue rather than as a whole. So IBC considers cases issue by issue. And this conforms nicely with the IAAIL model, widely taught in law schools, where we analyze a case into the issue, the rules governing the issue, not the case as a whole, the application of the rules and the conclusion. So I would argue that thinking in terms of issues rather than cases conforms to this widely used method of visual analysis. The issues form a logical model. They're related logically, and so there's no need to balance them. Once the factors are resolved and the various least nodes are known, then we can infer the conclusion. So what is the role of factors? The role of factors is to determine the least of the logical model. Each issue is associated with a small group of factors. Factors can relate to more than one issue. And because fewer factors are involved at the issue level, the decision is much more likely to be constrained. There are 8,192 possible antecedents for both the defendant and the plaintiff in case. So imagine the size of the lattice that we have to the past law. However, there are never more than 32 possible antecedents for any issue in IDP. And this enables us to ignore irrelevant distinctions. In the paper, I have a full worked example, but because of the time available, I will jump straight to the last page. The case in question is Boeing, which considers certain manufacture of aircraft windows, cockpit windows. There are a number of relevant precedents: national instruments, television, which is about a PBX, and Bryce, which is about software methodology. And we can see that these cases are, in some respects, similar to Boeing. Boeing is identical to television on the grounds of secrecy, and it's identical to Bryce with respect to the confidential relationship. None of the issues are in Boeing are opposed. Information valuable simply is accepted, and improper means of info use was established by the use of respective material. So we really want Boeing to be constrained because television solves the issue of secrecy, and Bryce solves, or rational instruments, which Bryce followed, solves the issue of confidential relationship. But on both the results and reason models, F1 will distinguish television, and F10 will distinguish Bryce and rational instruments. It's only if we think in terms of issues that we can constrain Boeing using television for secrecy and rational instruments for confidential relationship. And this is what we've done. So the argument is that we actually need to incorporate the main knowledge, the knowledge of the structure of cases represented by issues. This is because we want motion and we want mowing to be constrained by the precedent in the example. And issues are needed so that the irrelevant differences can be ignored and the cases constrained. Preferences are correctly located at the issue level. And this was recognized by Carl Brankin as one of those 1991 newspaper losing the portion perspective. It was exploited by IBP in ICAIL 2003, but it's still currently not exploited in the former House of Presidential Constraint, as represented by Henry Paperwork. Also, for explanation in terms of value, issues allow value origins to be local to issues rather than global, and the global requirement has presented problems in the past for value-based explanation. Now for come on to the third topic, factors of magnitude. Many factors seem to have a continuous favour. The number of disclosures from bulk to many thousands. The extent of security measures from minimal to profound. The ease of research engineering. I know that at a glance, but it may take me several years of study and experiment. The length of stay in various domiciles. And all these look like dimensions rather than factors. So how do they work with presidential constraints? This has recently been explored by the usual suspects, John Halsey, Adam McConey, Henry Clapham, and even by myself to some extent. The question is, do we need to change our account of presidential constraints to accommodate dimensions? And our answer is no. Presidential constraints uses factors, not dimensions. And the reason for this is reasoning with precedents involves two stages. Firstly, we identify the factors, sometimes termed intermediate precedents in the literature, on the basis of facts. And we find this in jurisprudence, Rossi's taboo paper. We find it in AI law, Ashley and Bloominghouse. We find it in jurisprudence again with Lars Lindau and others, and we find it in AI law in Clapham et al. Identifying constraining precedents by comparing factors is the second stage. We got rid of the dimensionality in the first stage. Consider, for example, disclosures. The number of disclosures is a dimension, ranging from bulk to very many. However, the particular number of disclosures in a particular case is a fact. If it's no, the dimension is particular, there's no factor. If it's a very small number, there is no factor because it's not significant enough. If there are many, the factor is less 10. And if it's in the public domain, the factor is less than 7, the very strong dependent factor. And of course, which factor applies may be determined by precedent. I also want to say something about trade-off. Sometimes factors are not independent. Look at the example from Clapham and Southwell used by John Halsey. This concerns the same as fiscal homicide. It depends on the length of stay and the percentage of income from abroad. The shorter the stay, the bigger the percentage needed. Absence and percentage, as I mentioned, and in a particular case, the particular absence and the particular percentage of fact. The factor is income sufficient is an absence. And once the factor is realized, we can apply presidential constraint to receive in terms of fact. As an example, consider the trade-off between income and absence. There's question 1 at 66, question 2 at 28, and question 3 at 2010. Clearly, there's a trade-off because we have the same percentage, but a different factor because of a different length of stay. The precedents show that this area, the area to the northwest of the line, does not apply, and the factor applies northwest, but it does not apply southeast of that line. And so we can fit a line to show the trade-off. Several lines are popular. This one is most generous to the most generous. So,
Trevor,
to summarize, there are different roles for questions.
sorry, Mr. Trevor, 5 more minutes, okay?
I've only got 2 more slides. There are framework preferences identified by the Zomi and the IAAIL 2015. And these tell us what the issues are. And the issues can also come from statutes and documents that the statement before. Then there are restriction criteria, and these determine whether a factor applies on the fact. E.g., 12 months is a short stay, 3 years is a long stay. And we can use either the results or the reason model for factor restriction. Finally, there are traditional preference questions. These are the standard sort of questions found in paper. And these establish which side has to respond to these. And they may also indicate values. And that's all.
Now we have the questions and answers session. Mr. Trevor, the first question was done by Prakan, and the question is, does your account of factors and dimensions principles that for every value of a dimension, it can be determined which size it favors, if any?
Yes, a judge always has the power to say that this dimension favors this side or that side for the future. It may not be constrained by precedent, but if it's not constrained, a judge can and indeed must make the decision.
Okay, thank you, Mr. Trevor. And the second one is, can you think of difference on civil law and common law systems when analyzing decisions using precedential constraints?
Sorry, can you repeat that? I got a bit of noise here.
Can you think of difference on civil law and common law systems when analyzing decisions using precedential constraints?
In civil law, precedents are used more to guide than constrain, but the general reason involved is, I think, very similar.
Yes, and the last one, the role of issues in legal reasoning is similar to the role of values in deciding among competing factors.
Can you repeat that? Sorry. Can you repeat that?
Yes, I can say it again. The role of issues in legal reasoning is similar to the role of values in deciding among competing factors.
I'm not quite sure I think that. I think that values decide amongst competing factors, but factors compete to resolve an issue.
Okay, I think the last one, in providing further criteria for deciding among competing factors. I think it's the same question.
Okay. Thank you.
Okay, I think that's it. Thank you very much, Mr. Trevor. I really appreciate it.
Thank you. Sorry to be so much trouble.
Of course. So our next speaker is Masaharu Yoshioka, who I would like to introduce to the audience. And he will present the paper BERT-based ensemble methods with data augmentation for legal textual entailment in COLI statute law task. So Mr. Masaharu, you have 10 minutes of speech, and afterwards we will move on to the questions. The stage is yours.
Yes, thank you. Thank you, Chairman. My name is Yoshioka from Hokkaido University. Today, I'd like to introduce our research titled BERT-based ensemble methods with data augmentation for legal textual entailment. So in this talk, we would like to introduce our system that participates COLI 2021 Task 4 Statute Law Entailment Task. This is the format of the data for the task. A pair of questions and articles are provided. The system should estimate the label for this pair by checking whether the article entails the question or not. In this case, answer is yes. So recent development of deep neural network-based NLP, these tools are also used for this task. In the last COLI, the best performance system uses BERT as a core module. BERT is a tool that can be used for semantic analysis tasks by the pre-training for general semantic understanding task using large text corpus. Based on this training, BART can be served as a general semantic analysis tool by fine-tuning with small training data. Even though the best performance system works well at the CORI 2020, but there are several issues remain. One big problem is lack of training data. We only have 3 small examples of 806 pairs. Another problem is variability of the question. The good performance system for the data of a particular year may not be good for the other year data. In order to tackle these issues, we propose a method to make new training data systematically, and we also propose a method that can handle variability of the questions. In order to make new training data systematically, we classify the type of mismatch for entailment. So this kind of data making process can be called as a data augmentation. That is a technique for machine learning by increasing the data using original data. There are 2 types of mismatch in the for making such a kind of pairs. This is an article. Is a judicial act performed by an adult word is voidable. So when we replace the adult word to adult, this is a semantic mismatch. We cannot entail the such kind of question from this article. Another type of mismatch is a logical mismatch, that is flipping the decision, adding not or removing not. It's not so easy to appropriate set of such semantic mismatch pairs, but it's much easier to make this type of logical mismatch systematically. Based on this understanding, we propose a method to create logical mismatch data systematically. For the positive example, we pick a pair of sentences about judicial decision in the article for the question part and article parts. The same sentences are used for these 2 parts. Negative examples are made by flip judicial decision of the sentence statement in the positive example to make logical mismatch. We flip the question statement. Most of the case, we add or remove not for the question statement for negative example. This is an example of making augmented example. This is the original statement. And from this statement, it says that may not. So we copy this statement to the article part. However, for the question part, we remove not from there. So because of that, this article cannot entail this question statement. So based on this training data, we train a BART-based entail system that is for original, that was proposed in the original BART paper. In this framework, BART estimates whether the question is entailed by the article as a binary classification task whose input is a combination of question and question and article with combinatory symbol set. The system calculates probability of entail or not as a result of the estimation process. So in order to understand the effectiveness of our proposed framework, we conduct preliminary experiments. This is a parameter of the BART is as follows. So we use BART Japanese model constructed by Inui's laboratory at Tohoku University with following parameters. We select minimum validation loss model using validation data. By using this method for 768 articles, so by using this data augmentation method, we construct 331 pairs generated as augmented data pairs. And we also split organizer-provided training data into training for the preliminary experiment, 695 pairs, and the testing for 111 pairs. And this training data are also split into training and validation, 9-to-1. So we all have, finally, we have almost 4,000 pairs for the training. 70 sentences for 70 pairs for the validation and 111 pairs for testing. In order to checking about the variability, we made 10 models using different randomly selected training set. This table shows the performance of the generated models using validation loss, validation accuracy, and the test accuracy. As we can see, the performance of the system are not so consistent, even though we use almost same framework for training the models. In addition, validation accuracy is not directly related to the performance of the validation accuracy and the test accuracy. So it is difficult to select appropriate model using validation accuracy and validation loss. In order to evaluate, based on this understanding, we try to make a proposal for making an ensemble models. In order to evaluate the effectiveness of this idea, we also conduct preliminary experiments for ensemble setting. In this experiment, we check performance of the combination of different models for ensemble. In this ensemble process, the average probability of positive and negative from the target model and select one whose probability is larger. We calculate accuracy for all combination of these 10 models. We select the pair set that uses 3 to 10 models from them. This table shows the result of the ensembled data. The best performance system uses 7 models, and the second and the third best system uses 3 models. On the contrary, the performance of the system using all models is worse among all settings. From this result,
Nishioka,
yeah.
You have 2 minutes.
Yeah, thank you.
Sorry.
From this result, we found that simply adding of the model may not be good for improving the performance. So it is necessary to have a mechanism to select the appropriate set of models for ensemble. So we use evaluation data because these 2 sets are good for the testing of the training data. We're picking up these pairs for the one of the best performance system of the submission system. We submit 3 results with different ensemble setting. Our system achieves the best performance among all submissions. From 81 questions, we can answer correctly for 57 answers. The accuracy is at 0.70. And we also compare the performance of the accuracy of previous year's data. The model is not so consistent. However, when we compare the result of the system with other participant system, our 18 runs are submitted in total. It means these questions are almost all system can answer correctly. And these questions are questions almost no system can answer correctly. Our system is very good at making good answers for the easy question, but we still have a difficulty to answer that difficult question. This is an example of the difficult question that includes semantic matching, anonymization, symbol treatment, and so on. So BART model itself can handle some semantic information, but there are so much big semantic gap between this question and articles. In such a case, we fail to analyze such a kind of statement at this moment. So this is a summary of my presentation. We propose a statute law legal entailment system based on BART with making new training data that consider logical mismatch using systematic approach as data augmentation. we also propose a method for selecting appropriate set of bird-brain model for ensemble. We confirm the effectiveness of our approach using CREE 2021 test data. Thank you for listening. This is the end of my presentation.
Thank you, Mr. Yoshioka. And now we are going to the question and answer session. The first question is, for a legal perspective, is it possible to analyze and relate the output, yes or no, of your bird-based system to any possible legal explanation to that?
Yeah, it's a very important point we have to discuss. At this moment, since our system just say yes or no, so this is just a starting point, and maybe as you can see some neural network, deep neural network based analysis. Maybe we have to think about such a kind of attention. So these two parts may be related or something, can be lead to such a kind of explanation. But at this moment, we cannot start such a kind of analysis. So yeah, at this moment, this is just a result without explanation. So we also think about how to generate explanation based on this result later.
Okay. And the second question is, can you think of difference between the Japanese judicial system to another law system in the world, like the American? And if you did, do you have suggestions of adaptations you could do to your work?
Yeah, so yeah, in the CORE task, we have a Japanese version of statute law task and the Canadian case law task. So the case law task have a much more case oriented. So most of the case, statute law only mostly contains the legal terms. The difficulty is the matching between the legal terms of normal terms exist for the cases. But case law matching, we also think about some matching of the normal terms and normal terms that consider the role of the judicial legal terms and so on. So the situation is not so, maybe it's not easy to say this is for American, this is for Japanese, but for the case law and the statute law, there should be some difference.
Okay, perfect. I think that's it because we don't have more time.
Yeah, thank you.
Thank you very much. I really appreciate it.
Yeah.
And now we are going to our next speaker, that is Ms. Sabine Weinert, who will present the paper Legal Norm Retrieval with Variations of the BERT Model Combined with Tf Idf Vectorization. So, Ms. Sabine Weinert, you have 10 minutes of speech. And
yes.
Afterwards, we will move to the questions. The stage is yours.
Can you hear me? Hello? Yes, I think you can hear me. Okay, good. I will just start. Welcome to our presentation on legal norm retrieval with variations of the BERT model combined with Tf Idf vectorization. My name is Sabine Weinert, and together with my colleagues, we have also participated in the COLI competition. And our approach is for task 3 of the COLI competition, which is statutory law retrieval. So this task is about having a query that describes some situation or a statement simply, and you have to retrieve articles that are relevant with respect to that query. And this can be one or multiple articles. So the data set at hand that we used is the English version of the Japanese Civil Code, and we have fewer than 1,000 instances. And as I already mentioned, multiple articles can be relevant. So in the past 2 years, the best approaches were different. Sometimes it was a deep learning approach, sometimes it was a traditional machine learning approach, as we can see here that in 2020, the team LLNTU won with a BERT ensemble that comprised of 3 models. And then in 2019, the University of Alberta won with with Tf Idf and lemmatization, as well as stop-word filtering. So that was the reason for us to combine those two approaches and see if they could benefit from each other. And also, since we consider here retrieval also as a problem of not so many instances in this data set, in this case, we also were thinking about approaches to increase the number of instances and also enriching their content. We submitted 3 different runs, and the first run was our winning run. And this is here an overview picture of the workflow. So we used sentence BERT embeddings with Tf Idf, and you can see here on this picture that we have queries and articles, and that we pre-process them with different methods. So you can see that we have 2 stages of Tf Idf and then also sentence embedding. From that, we obtain the vectorized version of the article and the query, and then we compare those 2 with the cosine similarity after each pre-processing stage. And then finally, we compute the sum, normalize it, and then determine a threshold to have the final prediction whether this article is relevant to the given query or not. I would like to present you also some details on what we actually did. And the first thing I would like to present is the data enrichment. So consider article 177 about acquisitions of, losses of, and changes in real rights on the movables, and so on. So this article is not that different from the other articles in the wording in the civil code. And we thought we could make it more unique by enriching it. So the first idea we had was to use the information that we could obtain from the civil code directly. So the civil code has some sections and headlines, and we just thought that we can take those as metadata and then simply parse them out. So you can see for this article 177, we could then get part 2, real rights, chapter 1, general provisions, and so on. And we simply took this text and appended it to the original article text and then further processed it using the tokenizer and the Tf Idf vectorization. And here you can see that we also added some other crawled data from open source commentary that was originally in Japanese, but we translated it using the Google Translator API. And this open source commentary was then for this article 177. And for example, there were some concepts defined such as comprehensive succession. So this was also just appended to the original article text. The third enrichment we performed was to use the information from the task 4 that was on entailment that just Mr. Yoshioka has presented. And there we know that for this article, there are probably some queries that have a positive entailment label. And since we know that the entailment somehow indicates that the meaning is the same of this article and the query, if this is a positive label, we thought that we can also use it for document enrichment. And so we also appended all queries that have a positive entailment label to this article. That was the data enrichment. Now we talk about the 2-stage Tf Idf. This is actually quite simple. So for both stages, we just used sublinear term frequency scaling and L2 normalization. And then the only difference between the 2 stages is basically how we enriched the articles. So stage 1 has the article with the metadata from the hierarchical structure of the civil code, and as well the article with the relevant queries from the entailment information. And stage 2 has only the metadata from the hierarchical structure. And at this point, you may wonder, well, why didn't you just take stage 1? And so we have made some comparison of just taking stage 1 and just taking stage 2. And there, usually the combination worked best. So on validation data, we saw much improvement. And on the test data of the Colli competition, we just had almost no difference between stage 2 and then the combination. So combining this didn't harm and also could give a benefit. And then finally, I would like to show you some details about the sentence embeddings we took and the thresholding mechanism. So the sentence embeddings come from a BERT model that's called sentence BERT, and it has been proposed by Rimus et al. And here they have used the Siamese architecture that encodes the query and the articles separately, but then there's some parameter sharing between the weights that are then learned during the classifier training. And what we also used was a pre-trained model from those same authors that's called Paraphrased as the Roberta base. And this model is particularly well suited, according to those authors, for natural language inference tasks. And since this retrieval task is also pretty hard, we thought that it could also benefit from such a model. And then the thresholding, for this, we have taken a kind of hard-coded approach that also was then simply saying, okay, for some index value, we have a specific similarity threshold, and then this article is included if it fulfills this condition. So with this run, we achieved the first rank in the collie competition with an F2 score of 72%. So precision and recall were quite high and balanced almost, and that's why we won in this case. There were other approaches that had a higher recall than we had, but well, F2 was then the measure that determined the winner here. And then let me just briefly also tell you about the other two runs that we submitted. One is Legal BERT with Tf Idf. There we used the BERT model as a classifier for retrieval. And as a basis, we used the Legal BERT-based uncased model. Well, and when you have a classifier for retrieval, you have the challenges of relevance class imbalance, because usually just a few documents are relevant and all the others in the corpus are irrelevant. And we also have the small data set. So this is quite a challenge for a deep learning approach. And what we did to make this a bit easier for our model was to decompose the data, in the sense that since we know that there are instances that have one query and multiple related articles, we decomposed them in pairs of one query and one article. So these were then sometimes multiple instances. And also we kept the original one where we had the articles still glued together as another instance in the data set. And what we also did was to decrease the number of irrelevant articles by just choosing the top 50 most similar non-relevant articles to a given article, because it's maybe more like it's harder for a model to determine why are those articles not relevant, although they are similar to a given relevant one. So that was our approach here. This is just the pipeline, the final one, where we have the Tf Idf, cosine similarity, then max normalization, and then we perform the arithmetic mean between the values from the Tf Idf and the legal BERT. From the legal BERT, we have the softmax for the relevant class, and then we have also some final thresholding. With this approach, we achieved an average position. So we were position 9 here, an F2 score of 67%. Well, and here you can also see recall was high and precision was a bit lower. So probably more advanced methods and thresholding would have helped here. And maybe this approach would be even also better than our first run. And then very shortly, the last run, that's the BERT score. So that was a pretty easy thing that we did, because it's based on an already available implementation. And what the BERT score does is that it simply computes the maximum pairwise cosine similarity between token embeddings that we obtain from a BERT model that is pre-trained. And so what you can see is that we have our training data, then we perform the BERT score computation, and we obtain an F1 score for the matching. And then we also just determine a threshold based on this F1 score. And here we were actually the last position, so we have the whole spectrum in the quali competition. And with this, we can also see directly, if you look at the values, that the precision is pretty low, and this is the reason why we were so bad, because recall is actually quite okay, but we probably have made a bad threshold decision or also overfitting in this case. So just to conclude, we found that pre-training and model architectures can play a vital role in using BERT for retrieval, and in our case, task adaptation and architecture, as we have seen in run 1, were better than domain adaptation in run 2. And also adding Tf Idf to the model improved performance. And then further takeaways are that data augmentation, decomposition, and enrichment are useful. And we also found that BERT approaches require much tuning and experimentation. So if you try to recreate this from scratch, then you might not get the same results that we have, because there are random parts of the BERT model, and then learning can be very different if you start the process a second time. With this, I conclude my talk. These are some selected sources, and now I am ready to answer some questions.
Okay, thank you, Sabine. It was a really nice presentation and really interesting. So we have here one question. That is, one of your remarks was the benefits of incorporating external knowledge. In your opinion, what could be other structured external knowledge that could lead to an improvement in results or in explanation of its outputs? A rule-based knowledge could help on that in any way?
Yes, I think so. For example, we could try to find out how the query, like some characteristics of the query, if this query describes a particular situation, if there are person relationships, if we can maybe classify those persons as some kind of entity. So classification could help there, and also probably a rule-based one, just when some term is present. I think those rule-based approaches are very often also applied for the subsequent task of entailment detection, but probably for retrieval it would be also a viable choice. Yes, and regarding explainability, I mean, this is also a deep learning approach, so we are rather on the lower end of explainability. The only thing we could do is to check activation values or also analyze subpopulations of interest. So if we want to find out some parts of the data set, maybe particular hard queries, if we are good at those, or queries that then also describe particular cases compared to cases where we just have a query that almost has a direct overlap with article text. So we could try to also segment the data set and then find out where we are actually good at.
Okay, so due to the lack of time, we will finish for now. So thank you very much. And now our next speaker is Hui Shu, who will present the paper Towards Summarizing Case Decisions via Extracting Argument Issues, Reasons, and Conclusions. Ms. Hui Shu, you have 10 minutes of speech, and afterwards we will move on to the questions. The stage is yours.
Okay, thank you. I'm gonna share my screen now. Okay. So can you see my screen?
Yes, yes.
Okay, that's perfect. So hello, everyone. It's a pleasure to be here. Today, I'm going to present our research paper of Towards Summarizing Case Decisions via Extracting Argument Issues, Reasons, and Conclusions. So I'm starting off the motivation of our project. Why summarizing a case decision is so important. The legal summaries are a necessary tool for legal practitioners to analyze a huge amount of legal material. Unfortunately, not all the decisions have the high quality summaries. The reason for that is simply because it's too costly to do that. So automatic legal summarization could help legal professionals and the public to access legal information with much lower cost. So in our study, we try to use our argument mining to improve the legal case summaries by picking up those sentences that comprise important issues, reasons, and conclusions. And we hired law school students to annotate those key information in expert prepared case summaries and 4 case decisions. There are 2 main contributions of our project. First, we employed an IRC type system for generating the succinct summaries. And second, we experimented an intermediate structure of mapping a mapping of the key information IRCs from the summaries to the full texts. So what is a legal argument triplet? We segment a legal argument into 3 elements: issue, reason, and conclusions. We refer to this key information as legal argument triplets, RC triple for short. So presumably those expert prepared summaries will have those key information. The benefits of using the IRC triple would help to clarify the case decisions and make it more accessible and transparent to its audience. Besides, it's an example of combining legal domain knowledge with argumentation that could supplement the machine learning techniques. This is an example of summarizing case decision using legal argument triples. So in order to get a high quality annotations, we hired law school students to do annotation or followed a detailed annotation manual for us. The annotators would do the annotation individually, and then we would resolve any differences between the annotations through the Zoom meetings with consensus of both annotators. This is a screenshot of the annotation tool we utilize for the study. Annotators would simply use cursor to mark the sentences according to the annotation manual. We also ask our annotators to do annotation for the full text. Instead of asking them to read through the whole the legal case decision, they would pick up the keywords from the annotated summary sentences as pointers, and then use them to locate corresponding sentences in the full text. Then we resolve any differences between the full text annotations as the same manner as for the summaries. The benefits of using this strategy is to help us to gather a sizable data set in a short period of time. And also it is the first step of projecting the annotations from the summaries to the full text automatically. Cohen-Kappa coefficient is used to measure the degree of agreement between the 2 annotators. The mean of the coefficients across the all types in the full text is 0.827. Given our experience and the task, it indicates a reasonable agreement about the nature, the type of the sentence types. So our annotated data set is based on the paired cases and summaries we received from the Canadian Legal Information Institute. The uniqueness of this corpus is all the summaries are prepared by the legal experts. Those cases have very rich legal information since they cover different kinds of legal claims and issues. In the current phase, we have already annotated 574 summaries and corresponding full texts. This figure shows the distribution of annotated IRC type of sentences in both summaries and the full text. As you can see, the non-IRC type of sentences are the majority in our annotated data set, which make our data set imbalanced. However, the manually mapping from the annotated summaries to the full text is still a very time-consuming task. So we decide to experiment automatic mapping from the annotated summaries to the full text, which is intended to decrease the annotation cost and improve the annotation efficiency. The strategy we use here is utilizing sentence border embedding, which would help us to derive semantically meaningful sentence embedding with fixed size. Then we use the sentence border embedding to calculate similarity scores for the annotated summary sentences with full text sentences, and then only keep the top 5 sentences with highest similarity scores for the further use. The novelty here is we're trying to generate weak labels by deploying the state-of-the-art sentence border embedding. Those are examples of automatically mapped IRC, the issue, reason, conclusion sentences. As you can see, the top ranked sentences often include the same keywords as the manually mapped sentences. We also find the reason sentences have fewer overlapping keywords than the other types. For the study, we choose different kinds of deep learning models to experiment, like the LSTM, synonym BERT, and synonym BERT models. Since our data set is imbalanced, we're trying to remedy the imbalance issue of our data set by using different kinds of loss function. There are three kinds of loss function we use here: the cross entropy, focal loss function, and the F1 loss function. For comparison purposes, we train our models on manually mapped data and automatically mapped data separately, and the F1 score is used to measure the performance of our models. This table shows the results of our experiments. As you can see, after training on the manually mapped data, the LSTM has the better performance on identifying the issue and the conclusion, and the synonym have the better performance on identifying reasons. After training on the automatically mapped data, the LSTM has the better performance on reasons, and the synonym BERT has the best performance on identifying conclusions. What we can learn from the results of our experiments? In general, the model performed much better after training on the manually mapped data than the training on the automatically mapped data. And we also noticed that the different models have their own strengths of identifying different types of sentences. For example, the LSTM has better performance on identifying issues and conclusions, and the synonym has the better performance on identifying reasons. We also noticed that the precision score decreased after training on the automatically mapped data. Our intuition about the decreased precision has something to do with the quality of the automatically mapped data. For conclusion, we confirmed that the deep learning model performed pretty well on extracting the IRC triples from the full text. And the loss function could mitigate the imbalance issue of our data set to some extent. The results of the automatic mapping shows the possibility for the automatic annotation in the full text. For the future work, we will continue to increase the size of the annotated data set, since the data size is not large enough for final comparisons in terms of the model performance. We also will explore more effective methods to identify the issues, reasons, and the conclusions. Finally, we would like to explore the possibility of generating the summaries by employing the automatic annotation. Last but not least, I would thank the National Science Foundation for supporting our work, and the Center for Research Computing for providing the computing resources, and our partnership with University of Montreal Civil Justice Lab and the Canadian Legal Information Institute for providing such a unique corpus for our study. Okay, thank you. So any questions?
Thank you very much, Ms. Xu. Now we are going to the questions and answers section. And we have some questions here. First, based on your investigations, what is the perspective to have better results from automated annotations?
So the first of all, I still will increase the size of the annotated data set. As I mentioned before, in the presentation, since our data set only comprised 574 the annotated cases, so it's not especially for the deep learning model, it's not large enough to give a very promising results. So the first thing we will do would be increasing the size of the data set.
Okay, and the second question is, when searching for annotation tool, which one did you choose, and why have you chosen it, and which limitations has the annotation tool?
Oh, the annotation tool. I have to thank for the second author, Jaromir. Actually, he is also of our annotation tool. It's personalized or designed for our specific task. This is the annotation tool we designed by ourselves. So it's not something you could search online. So generally, we have very nice experience of using this tool, and very nice. And you can see the screenshot I presented before. The layout of the annotation tool is very simple. The text column in the middle would be the annotators to annotate all the sentences for us. And there's a little menu would pop up if they select the sentences with 3 options. They would simply choose one of the options. And the sentences will mark the different colors according to the different types of sentences. Very easy to use.
Okay. Thanks. So I think that's it due to the lack of time again. So
okay, thank you very much.
I thank you very much for the presentation. It was really good. And
okay.
So we are going to our last speaker of this panel, which is Mr. Joe Colonet, who will talk about the paper From Formal Models to Implemented Tools, the ICAIL as a Case Study. So, Mr. Joe Colonet, you have 10 minutes of speech, and afterwards we will move on to the questions. So the stage is yours.
So thank you. My name is Joe Colonet, and I'm going to present this work, which I completed with Katie and Trevor from the Department of Computer Science and Constantine from the Liverpool Law School. So just to give you a bit of an overview, I'm going to start off with an introduction to our work, including some of the motivation about why we've chosen admissibility of cases as the problem to tackle. I'll then discuss how our model was implemented, both as a concept and practically. And then finally, I'll discuss the pilot study where our implemented program was used by a small sample of lawyers who work in the European Court of Human Rights. And then finally, I'll take some questions at the end. So we've developed a model that determines admissibility of cases that are submitted to the European Court of Human Rights. Admissibility in this case is whether the court will look at that case. And then if it's not admissible, then they don't look at it. And once our model has determined whether a case is admissible, it explains how it came to that decision. This is then implemented into a Java program and then we've obviously conducted a pilot study where we've given our program to a small group of lawyers. So just a brief introduction on the European Court. It was established in 1959, and it makes judgments on whether a member state has breached the European Convention on Human Rights. Decisions are mostly based on previous cases, such as in case law, but there is no specific requirement for the court to follow that in practice. So we've chosen admissibility specifically rather than the outcome of cases, as this is a major issue that the lawyers that we've spoken to have identified. So to kind of show you the scope of the issue, in 2019, there were 45,500 applications, approximately, submitted to the European Court, but only 90% of these were declared inadmissible. Only a small proportion of cases actually get to a point where a judgment needs to be made. And there's currently 50,000 cases in the European Court's backlog. So being able to speed up the ability to decide admissibility would massively improve a person's access to justice in Europe. So our model has been implemented as an abstract dialectical framework, or an ADF, using the angelic methodology, which represents case law as a factor-based hierarchy. So you can represent this as a tree structure, and at the root node, you'll have a violation, and then you have some children, which are the issues, and then but the children of those issues would be the factors, which can be base level factors or abstract factors. And each node in this tree will have some acceptance conditions to say whether that abstract factor issue is accepted. So for the legal foundations of our model, we looked at admissibility, and to decide that, we need to know whether it's within the jurisdiction of the European Court, and the European Court has a set of formal rules that every application needs to meet. And these are things such as the application needs to be submitted within 6 months of the violation happening. It can't be a trivial case. And by trivial, there are some exceptions. And it's the same with anonymous applications. Normally they don't accept them, but in some special cases they may accept them. And there's a whole list of other rules as well. So here's our example of an implemented model. So at our root, we have the node v1 that represents whether a violation of admissibility has occurred. And this is accepted when the two issues I1 and I2 are also accepted. And then issue 1 is accepted when the two base level factors and two abstract factors are accepted. Base level factors are represented as questions which reveal a fact. Abstract factors can have other abstract factors or base level factors as their children. So this was all implemented in a Java interface, and it asks each of the questions from before, one after the other, until a decision can be made. Once the decision is made, it then gives gives the answer out, and it also gives the explanation as to why it came to that reasoning. And all questions are phrased as yes or no questions. So here's an example of what would happen at the end. So you get the so the decision's at the top, and then the explanations in the text box underneath. So in this example, the application won't be registered, and that's because the applicant doesn't have legal representation. The application form wasn't signed, so these would have been base level factors, so questions that would have been given, and we can infer through the issues that not all signatures have been provided, and that the application doesn't comply. Now, obviously, the ADF is a lot bigger, but we only when we generate our explanation, we only take the parts that the user have answered and is actually relevant to the decision that's made. So we don't just show everything in one go. So when we finished making this, we sent it off to 4 lawyers who work within the European Court of Human Rights. And once they had a play with the program, they completed a survey which had 11 multiple choice questions. And these questions, you could have a positive or negative result. So it's to strongly agree, agree, disagree, strongly disagree. And these covered things such as functionality, usability, explainability. So whether the program functioned, how usable the program was, what they thought of the quality of the explanation, how useful they would find the program, and what they thought of the questions that we posed within our program. And so in our results, we had largely positive across the board, which was very nice to see, even though there's very few. And to conclude, so obviously we had some very positive results from the lawyers, and we can generally take away that lawyers do want technology to help them with the issues that they are facing. But they're also not computer experts, so we can't have anything that's too complicated or difficult to set up. So our future developments have tended to lean towards web-based systems. Okay, thank you very much for listening, and I'm happy to take any questions.
Okay, thank you very much, Mr. Colonet. It was a really good presentation, lovely.
Thank you.
And about the questions, when working with the experts, which which you think were the main limitations to cooperate with them to do the work?
So when we created the questions, I first went through the booklet that they give to the lawyers to explain how admissibility works, and then I created a set of questions, and then I spoke to them, to the lawyers about it. It generally went well. The biggest difficulty was finding things that weren't explained to in the documentation that was given. So there was often hidden things. It's usually some exceptions to the questions that were given that needed to be added in. So it's usually trying to find little finicky parts of the law that, as a lawyer, you don't really understand.
Ah, okay, I get it. And another question is, this work was modeled, think about case law judicial system, right?
Yeah.
Or so have you, okay.
So yeah, it is case law for the most part for the European Court, but they're not bound to it. So they will typically, in almost all cases, they'll refer to a previous case, but there have been some, it's usually when it's a massive change so whether, I think it's things like whether homosexuality is allowed to be in a same-sex marriage, things, big changes like that tends to be where it doesn't rely on case law.
Okay, that's nice. And what do you think about the future of this work? Which will be ultimate goal, let's say?
So what we've been working with is trying to find ways of the lawyers or users, so people who apply to the court can then use this program. We're trying to simplify some of the questions, make it easy to users, so that instead of submitting this case and then it gets put into the backlog before someone generates it, they can then see how to make a good application, if you like, to the court. And they will be able to understand it a little bit better. And the court then gets better quality applications.
Okay, that's really cool. Okay, so I think this is it. It is the end of the presentation and the end of the panel. So thank you very much to all the speakers, Mr. Bench Kapun, Mr. Yoshioka, Ms. Sabine Wennert, Ms. Shu, and Mr. Joe Colonet. So now we will have a short break of 30 minutes, and we will see you in the event. So thank you very much, and now we will have the break.